Okay, we have this question. We are given that integral 0 to pi 5 raised to the power of cos x times 1 positive cos x times cos 3x positive cos squared x positive cos cubed x times cos 3x times dx over 1 positive 5 raised to the power of cos x is given to be as k pi over 16. We are expected to find the value of k. You can pause the video and try this question. When we come back, let's check the answer out. Okay, I hope you all have got the answer. Let us see what the answer is going to be. Now we know this integral formula. Integral 0 to a f of x dx can be rewritten as 0 to a f of a negative x times dx. So utilizing this, x is going to be pi negative x. So wherever we have x, I'm going to substitute pi negative x. So let me start off by considering I to be equal to this. So this is going to be equal to integral 0 to pi 5 times cos of pi negative x times 1 positive cos of pi negative x times cos of 3 of pi negative x positive cos squared of pi negative x positive cos cubed of pi negative x times cos 3 of pi negative x. The entire component is product multiplied with dx, okay, divided by 1 positive 5 times or 1 positive 5 raised to the power of cos of pi negative x. Okay, so this is what we have got. Now we will have to simplify this. Let us see what the simplification is taking us to. So this can be rewritten as, now we need to know that cos of pi negative x is actually negative cos x. So this is going to be equal to, I have an I here, integral 0 to pi 5 raised to the power of negative cos x times 1 positive. You have a negative negative positive, so you have just cos x times cos 3x. This is squared, so you have cos squared x positive. This is negative negative, again you will have a positive, so there won't be any change. So you have cos raised to the power of 3x times cos 3x times dx divided by 1 positive 5 raised to the power of negative cos x. Now this is okay. Let me write one more step. So this is going to be equal to integral 0 to pi 5 raised to the power of negative cos x times 1 positive cos x into cos 3x positive cos squared x positive cos cubed x times cos 3x divided by, this is going to be 1 positive, I can rewrite this as 1 over 5 raised to the power of cos x. So you can simplify this. So this is going to be, the denominator is going to give me 1 positive 5 raised to the power of cos x divided by 5 raised to the power of cos x, and you have a 5 raised to the power of negative cos x times 1 positive, this is 0 to pi cos x times cos 3x positive cos squared x positive cos cubed x times cos 3x times dx. So you flip it, this is 5 raised to the power of cos x, this is 5 raised to the power of negative cos x, so they get cancelled. So you have the quantity integral 0 to pi 1 positive cos x cos 3x positive cos squared x positive cos cubed x times cos 3x divided by 1 positive 5 raised to the power of cos x times dx. This is my 2 and you have I here. So what I'm going to do, I'm going to add 2, I'm going to take this as 1, okay. So on the left you have I and I, so they get added up. I'm going to go to the next page. So this is 2 times I is equal to integral. Now if you observe, we have 5 raised to the power of cos x and this entire term. Now I need to write this entire term, 1 positive cos x cos 3x positive cos squared x positive cos cubed x cos 3x. Okay, cos cubed x cos 3x times dx. Now actually, okay, so what I'll do is I will just add them up. So positive 5 times cos x. Now this has got 5 raised to the power of cos x. This is the first term, followed by the second term 0 to pi. It's going to be 1 positive cos x cos 3x positive cos squared x positive cos cubed x cos 3x times the dx. Okay, times the dx is here, divided by 1 positive 5 times cos 3 cos raised to the power of x, right? So if you were to add it, this term is going to be the common factor. So 1 positive cos x cos 3x positive cos squared x positive cos cubed x times cos 3x. This is a common factor, and once I take it out, I will have a 1 because of this, and positive 5 raised to the power of cos x, right? Okay, divided by 1 positive 5 raised to the power of cos x times dx. So these two gets cancelled. Okay, so we did all these things just to get rid of this term. So this is 2 times I is equal to integral 0 to pi 1 positive cos x times cos 3x positive cos squared x positive cos raised to the power of 3x times the cos 3x times the dx. So now we will have to perform some manipulations. Now foremost, what I wish to do, I will start with the cos squared x. Now cos squared x has a representation as 1 positive cos 2x by 2, right? So the fact is that we need to somehow have a 2 there. So let's see what we can do with that. Okay, so as I mentioned to you, we do not have the 2 there, so I'm bringing this 2 down. But apparently if we were to use this representation, then we will have to deal with this too. So what I want to do is I will multiply and divide by 2. So this is going to be 1 over 2, and I will multiply 2 throughout. So it's going to be 2 positive, and this will also have a 2 times of cos x times cos 3x positive 2 times cos squared x positive 2 times of cos cubed x times cos 3x times dx. Okay, so limits are 0 to pi, and you have 2 times I. So now I can very well apply cos squared x is equal to, in fact, 2 cos squared x is equal to 1 positive cos 2x. So that's going to be the change. So it's going to be 1 over 2 integral 0 to pi 2 positive 2 times cos x cos 3x positive 1 positive cos 2x positive 2 times cos cubed x cos 3x times the dx. Now 1 can be added to 2. It's going to be 1 over 2 integral 0 to pi. So that's going to be 3. Now you have 2 times cos x cos 3x. This is a product formula, so we can convert it to the sum formula, and that is going to be cos 4x positive cos 2x. Okay, followed by cos 2x positive 2 times. Now cos cubed x, there is a formula for cos cubed x. Now we have this representation, 4 times cos cubed x negative 3 times cos x is equal to cos 3x. Now I want to get rid of this cos cubed x. So what I'm going to do is I'm going to rewrite this as cos 3x positive 3 times cos x divided by 4 is equal to cos cubed x. Fair enough, right? So in place of this, I'm going to have this. So let me go to the new space. Okay, so let's make that following substitution. So for sake of consistency, let me rewrite it as cos cubed x times cos 3x times dx. So this is going to be the continuation. So this is equal to 1 over 2 integral 0 to pi 3 positive cos 4x. Now cos 2x and cos 2x, they can be added. So it's going to be 2 times cos 2x positive 2 times, as I mentioned to you, cos cubed x is going to be cos 3x positive 3 times cos x divided by 4 times cos 3x, and this entire thing is product multiplied with dx. Okay, let me have it like this. Okay, that is quite a sum. So this is equal to 1 over 2, and I'm going to have 0 to pi. This is 3 positive cos 4x positive 2 times cos 2x. Now I need to reduce this. So this is going to be 1 over 2. Now cos 3x times cos 3x, that's going to be cos squared 3x, and this is 3 times cos x, so 3 times cos x times cos 3x. So you have 1 over 2 being present outside. This is multiplied with dx. Okay, so of course I don't need to have a parenthesis there. So this is equal to 1 over 2 integral 0 to pi. Now we need to set up these things. Okay, so this is cos squared 3x with 1 over 2. What I wish to do is I will have to use this formula 1 positive cos 2x, so we have to do that. Okay, so let me go back to the formula, which is cos squared x is 1 positive cos 2x over 2. Now we have cos 3x, so x is actually taking the value of 3x here, so this is going to be cos squared 3x is equal to 1 positive cos 2 of 3x divided by 2, which is going to be 1 positive cos 6x divided by 2. So in place of cos squared 3x, this is going to be the substitution. So let's place that. So this is going to be 3 positive cos 4x positive 2 times cos 2x positive 1 over 2 times cos squared 3x is going to be 1 positive cos 6x divided by 2. So this 1 over 2 is going all through, right? So this is going to be positive 3 over 2. Now I'm going to use, or I would say I will convert this product to sum. So if I were to do that, this is going to be cos of 4x positive cos 2x, okay, divided by 2, because we do not have a 2 there. Now this entire thing is actually product multiplied. This entire thing is product multiplied with dx. Okay, so we need to move on. So it's going to be 1 over 2 integral 0 to pi 3 positive cos 4x positive 2 times cos 2x positive 1 positive cos 6x divided by 4 positive 3 times cos 4x positive cos 2x divided by 4 multiplied with dx. So this is what we have got. Okay, so okay, all right, Now what I wish to do is I will like to simplify the components. So you have a 3 here. Now you have 1 over 4. It's actually 1 positive cos 6x over 4. So I'm going to split that as 1 over 4. And I'm going to place 1 over 4 here. Followed by cos 4x positive 2 times cos 2x is here. Now if you see here, you have 3 times cos 2x over 4. So we can make the split there. So to this it's going to be 3 times cos 2x over 4. Fair enough. Followed by cos 6x over 4. Followed by 3 times cos 4x divided by 4. So this is what we have got. So we can club these two together. Of course these two can be clubbed. So multiplied with dx. So this is going to be equal to 1 over 2 integral 0 to pi 3. 4 3s are 12, 12 positive 1, 13, right? 13 over 4 positive. Now you take the LCM as 4. 4 times 2 is 8. 8 cos 2x added with 3 cos 2x. That's going to give me 11 cos 2x divided by 4 positive. Now you have 3 cos 4x divided by 4. So that's going to be 7 cos 4x divided by 4. Right? Followed by cos 6x divided by 4 times the dx. Okay? To rewrite integral 0 to pi as 2 times integral 0 to pi over 2. This is perfectly possible. So this is going to be 2 times of 1 over 2, right? This 1 over 2 is taken out. Integral 0 to pi over 2, the limits is 0 to pi over 2 now. So it's going to be 1, 3 over 4, 13 over 4, 11 over 4, cos 2x, positive 7 over 4, cos 4x, positive 1 over 4 times cos 6x times the dx. This is what we have got. Okay, now 2 can be cancelled. That's good, but on the left I have 2 times I. Have that in mind. So 2 times I is equal to, I integrate this, I get 13 over 4 times x, positive 11 over 4. I integrate cos 2x, I get sin 2x divided by 2. I integrate cos 4x, I get sin 4x divided by 4. I integrate cos 6x, I get sin 6x divided by 6. So the limits are 0 to pi over 2. Okay, pi over 2 is there. Okay, alright, so this is equal to, if I substitute the upper limit 0 to pi over 2, I would have 13 over 4 times pi over 2, fine. Right, so when we substitute the limits, can you tell me what would be left? Apparently, if you substitute x is equal to pi over 2, sine 2x, substitute pi over 2, you get pi, sine goes off. Again you get sine 2 pi, sine goes off. Again you get sine 3 pi, sine goes off everywhere. So what is left? And of course 0 is going to give me 0. So all these terms goes off and also the lower limit vanishes. So what you got? You have 2 times I is equal to 13 over 4 times pi over 2. So this means I is equal to 13 pi over 2 times 4 is 8, 8 times 2 is 16. Now they are asking us to find the value of k. You see here? This is the original question. Find the value of k. So what is the value of k here? K is equal to 13. So that's the solution for this question. This is a lovely question. Students, please like, share and subscribe. Thank you.